Everyone, today we are going to talk about the water cycle and the mass balance equation for the water cycle using the conservation of mass principle. And as we can see here, we can see the tree, the ponding, and the snow pond, the soil water, recharge, percolation, discharge, the confined aquifer, unconfined aquifer, saturated zone, unsaturated zone, water table, and capillary flow. So firstly, we will talk one by one what these mean and what they do. Saturated and the unsaturated zone. If we see here, this is the water table, and the unsaturated zone are the area that are above the water table, and the saturated zone that is below the water table. So basically the unsaturated contains both air and water, and in the saturated zone, pores are completely filled with water only, no air. That unconfined aquifer is the area below the water table and above the aquitard, and the confined layer is the area between the two impervial layers. So here water is under pressure, so when we drill, the water level may rise above the aquifer top and also can form the arterial here. So infiltration is the water that comes from the ground surface to the below the ground surface, and recharge is the water that goes down from unsaturated zone to the saturated zone, and the percolation is the amount of water that goes from unconfined aquifer to the confined aquifer. Talk about the mass conservation of the mass principle. We know that the conservation of mass principle indicates the input minus output, and the change is equal to the change in storage. Here P equals to Q plus ET plus the storage change, where P is the precipitation, Q is the runoff, and the ET is evapotranspiration. Based on this concept, now we will talk about the mass balance equation for the different part of the water cycle, starting from the canopy storage. So if we see this area indicates the canopy storage. Here precipitation, when the precipitation falls drill to the ground, we call it a through, but when there is a tree or the plant and the precipitation falls on the trees or the plant, we call it the interception. A drip is the amount of water that goes down from tree or plants to the ground surface. ECS is the amount of water that is evaporated from the canopy storage. So for this, the mass balance equation is equal to the interception minus drip minus evapotranspiration. Mass balance equation for the unconfined subsurface aquifer is the area below the water table and above the aquitard. Here the recharge is coming from unconfined aquifer, and percolation is going downward to the confined aquifer. QGS is going outside, the discharge is also going the outside, capillary flow is also going outside above the unconfined aquifer. So for here, the mass balance would be incoming, the recharge minus the QGC minus the percolation minus the capillary flow and minus the discharge. Balance equation for the confined aquifer. Here if we see in this area, the only component contributing here is the percolation that is coming towards the confined aquifer, and discharge is going out from the confined aquifer. So here the mass balance equation would be the percolation minus the discharge from the confined aquifer to the unconfined aquifer. So based on this concept, we can easily calculate the mass balance equation for any part of the land surface or below the groundwater also.